Welcome back to Chapter 4, Section 1. This is Graph Quadratic Functions in Standard Form. Alright, first of all, let's talk what a quadratic function is. There's a lot of different ways you can say this. A quadratic function can be written in standard form. So the standard form is y equals ax squared plus bx plus c, where a, b, and c are numbers. Okay. Parabola is the shape or the graph of a quad. Graph of a quadratic function, and it's in a U shape. So it's either going to be like that or something like that. The vertex is the lowest or highest point. On a parabola. So basically this would be the vertex here, and this would be the vertex there. Axis of symmetry divides the parabola into mirror images. The mirror images. So the axis of symmetry would go right through there, or right through here. And that means the left side is equal to the right side. Minimum or maximum values. The minimum or maximum values are at the vertices. It's the vertex's y coordinate is the minimum or maximum value. So y coordinate at vertex. All right, now we're going to be spending some time learning how to graph these now. So the parent function of the family of all quadratic functions is f of x, or y, equals x squared. So they all start off as x squared, just like a parent function for the parent function for absolute values was y equals the absolute value of x. Parent function for linear equations was y equals x. That's how parent functions work. They're the most basic. They always go through the origin. The vertex is 0, 0. Axis of symmetry divides straight through. And so what you have here now is for f of x equals ax squared, and for any quadratic function where b is not 0, the vertex lies on the blank, and the axis of symmetry is x equals 0. Okay, so we're basically looking at anytime there's no, anytime any quadratic function where b is 0, which basically means this part is gone. Anytime this part here is gone, then the vertex lies on the y-axis somewhere. So the vertex is anywhere on this y-axis, and the axis of symmetry is the vertical line x equals 0. Now, right here, this TOV means table of values. You can always make a table of values, and if you get enough points, you should be able to graph it. So we're going to compare the graph of this to this. So we need to fill out this table of values. And you make this table of values by plugging a number in. So the first one -2 times, I'll put in 0 because it's the easiest one. So -2 times 0 squared plus 2 should be 2. So go ahead, pause the video, and try working out the rest of these. Alright, you should have gotten these as your values after you plug in all the numbers in for x. So you plot the points from the table. So -2, -6. 0, I'm sorry, -1, 0. 0, 2, 1, 0, and 2, -6. Draw a smooth curve through the points. So as nicely as you can, you draw a curve. And then you compare the graphs. So you look at this. You look at how the parent function changed from the child function. And you can see that they both have the same axis of symmetry. However, the graph you put on here opens down. And is narrower than the parent function. Also, its vertex is 2 units higher. So all you got to do is, mainly, this is the big part right here. 1, 2, and 3 are the most important parts. Knowing how to graph these things, these parabolas. But knowing that this flips upside down, that it's narrower and is shifted up is a very important thing. If you said the shifted up part, that's really, really the most thing I'm looking for the most. So for guided practice, number 1, you have the equation y equals -4x squared. Now, since this is negative, it's going to flip it upside down. But we're going to make a table of values. We're going to use -2, 0, and 2. And go ahead and pause the video, plug those in, get the y values out. All right, as I started filling these out, I realized -2, 2 are a tough choice for graphing this, but we're going to go ahead and go with it because -2 squared is 4. 4 times -4 is -16. Since this is a mirror image, 2 squared is 4 times -4 is -16. So we've got a dot at 0, 0. And then at -2, 1, 2, 3, 4, 5. I'm going to change this scale just so I can actually work it out. -2, 2, 4, 6, 8, 10, 12, 14, 16. Oh man, it goes way far down. It's about here. And then here. With a nice U-shape parabola that opens down. So if we're comparing these two things, comparing these two graphs, the parent function would have looked like this. So this graph is flipped and narrower. There is no shift. You can just realize here that you can graph using a table if you need be. All right, if you want an easier way to graph, this is how you set it up. This is standard form. The graph opens up if a is greater than 0 and opens down if a is less than 0. That means this positive, this negative. If the x squared part is positive, it opens up. If the x squared part is negative, it opens down. The graph is narrower than the parent function if the absolute value of a is greater than 1, and wider if it's less than 1. That basically means, for this one, if it's a decimal or fraction. The axis of symmetry is x equals, and this is the big one right here, it's negative b over 2a. And the vertex has an x-coordinate of negative b over 2a. So basically, I'm going to add an extra note here. The first thing you need to do when graphing is determine whether it opens up or down. Find the vertex by using negative b over 2a. And what you're going to do then is when you find negative b over 2a, you plug it in and you find the unknown y value. The third part is you get one more point, and you might be able to use 0c for this. And then the last one, you do a mirror image. And draw the curve. So the y-intercept is c, so the point 0c is on the parabola. So, take a look. Let's start off by identifying the numbers. A is the number in front of, or standard form, a is the number in front of the x squared. It's the negative 1. B is 4, and C is negative 3. So because A is less than 0, step 1, does it open up or down? You should say down. Finding the vertex, first calculate the x-coordinate, negative b over 2a. So b is 4. And a is negative 1. So when you calculate all of this, negative 4 over negative 2 becomes negative 2. That means my vertex is at negative 2, comma, question mark. So you find the y-coordinate by plugging it in. So you plug negative 2 in for x. Let's see here. Negative 2, negative 2 squared is 4. Minus 8, minus 3. Negative 12, negative 15. Oh, whoops. Hold on, everybody. Take a look here. Negative over negative is a positive. So these numbers here are mixed up. Should be 2. This number here should be 2. And it changes then pretty much all those numbers in there. It becomes negative 4 plus 8 minus 3. So that's 4 minus 3, 1. So 2, 1 is your vertex. We need now a second point. Oh, draw the axis of symmetry at x equals 2. Because the axis of symmetry goes through, it's a vertical line through the vertex. That's the axis of symmetry. The y-intercept c is, which is negative 3, means that you can plot 0, negative 3. And then you can mirror this point over 1, 2, 1, 2. And that's looking at 4, -3. And once you know the vertex and a point on either side, you do not need to evaluate another point. You just have to draw the best upside down U shape that you can. All right, moving on. Guided practice number 5. It's y equals 2x squared plus 6x plus 3. A is the number in front of the x squared. B is the number in front of the x. And C is just by itself. So, step 1 was to opens up or down. You should say it opens up. Finding the vertex, negative b over 2a. It's negative 6 over 2 times 2, which is negative 6 over 4, which is approximately negative 1.5. So part of my vertex is at negative 1.5. And now it's a matter of finding the y value. So at this point, you should have some calculators. You can do it by hand if you want. Go ahead and plug in negative 1.5 into x and see what you get. You should actually get negative 1.5 as the other part of your vertex, which is pretty interesting. All right, so you've got that it opens up. Here's the vertex. You need another point, which is 0, 3. And once you have all of that, you go ahead and set up your coordinate plane. Plot the point negative 1.5, negative 1.5. Plot the point 0, 3. You know that there's a vertical line coming through here. You know now that this point here gets mirrored over here. And so you get a perfectly nice U shape going through those points. That's your graph. Guided practice 6. Now you have negative 1/3 x squared minus 5x plus 2. So A is negative 1/3. B is negative 5. C is 2. So it's negative a value. So for step 1, it opens down. Step 2, negative b over 2a. Well, that'd be negative 5 or 5. All over 2 times negative 1/3. That becomes 5 over negative 2/3, which ends up being negative 15 halves, which 7.5. So once you put, I'm sorry, it should be negative 7.5. Don't forget your negatives. So once you put negative 7.5 in here and work it out, and hopefully at this point you have a calculator because the answer ends up being the y value is 20.75. 20.75. Part 3 was finding the second point, and for us it's 0, 2. And now, when graphing this, we're going to go by 2's. 2, Now when I graph this, I graph the vertex, negative 7.5, 7.5, and 20.75, 0, 2, and then there's another point over in this direction, and you have your perfectly drawn parabola. All right, so this next part is just like the absolute value equations. The vertex coordinate of a minimum value of the function, if a is, there's a minimum if a is greater than 0, and a maximum if a is less than 0. Basically, if it opens down, you have a maximum value. There is no minimum because this arrow goes on forever, so the minimum's infinity. You can't really do that. So then if it opens up, there's a minimum. All right, so tell whether the function has a minimum value or maximum value, then find it. Since a is less than 0, the function has less than 0. It means a is negative. If it's negative, then it has a max value. And you find it by finding the vertex. So x is negative b, the opposite, or it's negative b, so negative 12 over 2 times negative 3. When you work this all out, it ends up being negative 12 over negative 6, which is 2. So the x part of the vertex is 2. When you plug in the y, plug in to find the y, you end up with this. Which when worked all out equals 6. So the maximum value is 6. Guided practice number 7, find a minimum value for this equation. 4x squared, 16x minus 3. So we know it's minimum since a is greater than 0. We know that it's a minimum because it opens up, and this is the minimum value. So we look at now x equals negative b over 2a. So it's negative 16 over 2 times 4. That becomes negative 2. So the x value is negative 2. We need the y. So 4 times negative 2 squared plus 16 times negative 2 minus 3 gives us negative 19. You don't have to graph this. You just have to know that the minimum and minimum value is all the way down at negative 19. All right, let's try some of these now. We've got 4 check your understandings or checkpoints. Graphing this. You can use a table of values. You could look at this and say that this is just a parent function flipped upside down. So the parent function looks like this. All right. Flipping it upside down because of the negative. Now I'm going to do the fact that a is negative 1, b is 0, c is 0. It opens down because a is negative. The axis of symmetry, negative b over 2a, that would be 0 over 2 times negative 1. So it's 0. So the vertex is right here. The y-intercept is there as well, so we need to find one other point. Graph looks like that. This one's a little bit tougher. A is 1/3, B is 0 again, C is 3. Now if we were just looking at this, we would know that it just shifts up and is wider. But let's actually graph it and see. So note step 1, it opens up. Step 2, negative b over 2a. So negative 0 over 2 times 1/3 just ends up being 0. So when I plug that in, 1/3 times 0 squared plus 3, 0, 3. So what I have right now is I have that 0, 3 is my vertex, and then it opens up. We need another point. You can't use 0, 3 as your other point. So if I put a 2, let's put a 3 in there. Let's check the point 3 comma something. 1/3 of 3 squared plus 3. Well, 3 squared is 9, and a third of that is 3. It's 6. So 3, 6. Mirror image. And here's your graph. All right, let's do this one. We're almost done. A, B, C. A is 1, B is negative 4, C is 2. So in step 1, this opens up. Step 2, let's find the vertex. So the x part of the vertex is at 2. Now you plug it in. It's 4 minus 8 plus 2. Negative 2, I think. The vertex is at 2, negative 2. And we know it opens up. We need to find a second point. So this time let's use 0c, which is 0, 2. Let's do a mirror image on the other side of this axis of symmetry. And there's your graph. All right, find a minimum value, y equals 2x squared minus 6x plus 6. Well, for this, a equals a positive number, so it opens up, which means we have to find a minimum. And we do that by finding the vertex. So the x value of the vertex should be 1.5. When you plug that in, go ahead and plug 1.5 in for x and see what you get. And again, you get a 1.5. So the vertex is right here. The minimum value is that 1.5. All right, so you need to try as many of the other guided practices that you can, and we'll work on this part in class. Good luck.